The last part of section 3 in your chapter 4 notes talks about conditional probability. And basically the conditional probability is probability that you find when you know some other kind of condition beforehand. So conditional probability of an event is a probability obtained when additional information that some other event has already occurred. And the way you denote it, it has the same symbol probability, but it's like B, and then you have like a vertical bar A. So you'll have some kind of event first, then like a vertical bar, and then another event on the other side of the bar. The way you read this is it's the conditional probability of event B happening or occurring given that event A has already happened. Okay, so we want to basically go through how you solve this kind of probability statement. And this is the intuitive approach to finding those. The conditional probability of B given A can be found by first assuming event A has already occurred. Or what I do is I say that I know event A is what I have, and that actually gives me a new total. So this actually lowers your denominator from the total amount, like in your whole, your whole table. You can see a table we're about to look at. Your denominator will change because of the thing behind the bar. And then what's left over, we're going to calculate the probability of B from the leftover. Okay, we're going to go through a few examples down below. I think these probabilities are kind of my most favorite probabilities, but they do change one aspect that you may not be used to, and that is how the denominator changes. So in this problem right here, we want to find the probability of getting a negative test given that the subject didn't lie. So the bar, remember that little bar in the very middle means given. So we're given that. And what this is going to do for us is whatever's behind the bar is going to give us a new total. So if we're given that the subject didn't lie, we would actually only look at these people right here. Okay? Only look at these. Meaning we would completely dismiss the lie people. So how that works in our fraction is the back part of the bar gives us a new denominator, a new total, which means we have 42 people total. Of those 42 people, 30 of them had a negative result. So you kind of cover up the lie people because, if you're given they didn't lie, you're not even interested in the liars. You're only interested in the did not liars. So you're only going to look at 42 people. I just cover it up or cross it out so I don't even see it. And then of those 42 people, how many of those had a negative test? So this is kind of the only problem where you're actually changing the denominator. Most of the time, the total has always been our denominator. Except for these problems, it changes. So it definitely takes a little practice to get the hang of these right here. And this is basically the solution written out in words, but what we're really wanting to find is probability of selecting somebody with a negative test, given that we know that they didn't lie. And then the total amount of subjects in the table, if you counted them all up, it's 85. Normally our denominator has been that 85 before, but if we use the intuitive approach and assume that the selected subject didn't lie, that's what we're given. We always assume that last part of the bar is what we know. Then we narrow our total people we are selecting down to just 42 people. Then among those 42, we know that 30 of them had a negative test. And that's how you get your answer in 30 over 42. And you can make that a decimal or fraction, whatever, reduced fraction, whatever you want to make it for the problems on MyLabs+. But you get the idea there how that works. Let's look at this next one. I'm going to erase some stuff here real quick and change my pen color so that I'm not using the same thing. So I'm going to get rid of all that. let's use like the red color for this one. So what we want is didn't lie given negative test. So if we're given that they had a negative test, we're only going to look at negative test people. So only look at negative test. So what I do is I cross out everything that is not negative test, because that is going to be my new denominator right there. So I go to anything that's not negative test and cross it out. So, or cover it up with your hand, whatever you need to do. So I got rid of those top things that were positive test. I'm only going to look at 36 people. So that's 36 people. That's our new total. So you're given that they had a negative test. That means you would not look at positive people if you were given that you knew they were negative. So of the 36 people, how many of those 36 didn't lie? Well, what we haven't crossed out, the did not lie part, is 30 out of the 36. So 30 of the 36 did not, or 30 of the 36 didn't lie, given they had a negative test. And that's basically how you solve those problems. Let me do a couple more on the other like the other side. We'll make up a couple here. Let's say C. We're going to do probability of let's see. Let's do lie given positive test. And then we'll just change that around and do D, probability of positive test given lie. Probably should do that in a different color, both of them, but anyway. Let's change the color for this one. I'll use purple for this one. So this C part, what I'm going to do is cross out the people who are negative test, because I only want positive test people. So remember back here, this is what we're given. That we know this. To only look at positive test people. So we're going to cross out all the negative people. So I crossed them out. So that's going to be 12 and 37 will be 49. Of those 49 people, how many lied? We had 37 of them lie. And then you can make that a decimal or a fraction, whatever you need. Okay. Next, let's do blue color here for this next answer. Let me reset my table here. I'm just going to erase all the stuff I marked on it. I'm going to cross out everybody who's not a lie person. So only look at the lie people. So let's see how many people we have lie. Lie is, it's up and down, so I need to cross out all these do not lie people. I'm only going to look at those 43 people. And then how many of those 43 had a positive test? So I've crossed out all the did not lie. Those are gone. Positive test is 37 out of 43. And that's basically how you do those problems. And by the way, there's a problem right here that says, is it always true that when you change the order that they end up being the exact same answer? Obviously, that's going to be false. We got different answers. When we rotate and we change those around, 37 or 49 is not the same as 37 or 43. So those are actually not equal to each other. But anyway, that's how you do those last few problems on your homework, the conditional probabilities. I think those are kind of, once you get the hang of those, I don't think those are that bad. They're kind of quick and fun. So good luck, and let me know if you need any help.